Good morning. We are Group 6, and I'm Ho Yi. Our topic is ocean acidification, and that's our content. What is ocean acidification? The reduction of pH over the ocean? Or human-related global threats? Yes, they both are. Owing to the human activity, there's a high production of carbon dioxide by burning the fossil fuels, and the ocean has absorbed 1/3 of it, causing a change of pH balance and the raising level of lysocal. And the greater the expansion of the deep sea area, the higher the lysocal area will be raising, being the separation of calcium carbonate rich and absent area. The Lewis paper pointed out that the raising level will affect the diversity and abundance of marine above and below the area. Since the Industrial Revolution, this area has risen for all parts of the ocean, and there will be a greater loss of balance before the end of the century. This global threat has drawn our attention to invest more about its data and the consequences. So now let me pass it to another group mate to explain more to you.
For more information, ocean acidification reduces the availability of carbonate ions, crucial for classifying the organism, like corals and shellfish. The shell skeletons are beginning to dissolve. The organisms may be endangered and entire ecosystem become destabilized. Besides that, decreasing plankton populations disrupt food webs and ultimately reduce the food ability for countless communities. According to CCSM3 models, shows that the mean pH value at the sea surface center around the year from 1875, 1995, 2050, and 2095. From a pre-industrial values of 8.2, surface water pH is projected to drop to around 7.8 by the end of this century, and increasing ocean acidity by 150%. While certain regions like the Atlantic and Pacific maintained higher pH and carbonate ions level, the Arctic will face undersaturations of aragonite by 2050. By 2095, the all southern ocean, south of 60 degrees south, and part of the northern Pacific will also be undersaturated of aragonite. Besides that, nations with large coral reef areas or that catch and consume large amounts of food and shellfish, and those located at a high latitudes are likely to be the most vulnerable to ocean acidification. Japan is the most vulnerable nation to the impact due to its the 10th largest consumers of fish and a key player in fishing and shellfishing within its exclusive economic zone. France ranked the second while the UK ranked the first. As ocean acidification increases, countries with high fish consumption will be most exposed to interaction of their dietary choice.
Now, I'd like to highlight some important international conferences focused on ocean acidification, showing how severe this global concern is. First, we have the Ocean Acidification International Conference Series, targeting on solving problems related to this phenomenon. Then, we have the International Coral Reef Symposium, which focuses on the health and sustainability of coral reefs that are significantly impacted by ocean acidification. Moving on, there is the Ocean Sciences Meeting, which emphasizes discussion on impacts of ocean acidification on marine ecosystem. Next, the Global Ocean Acidification Observing Network workshops fosters the research on this problem. And finally, the Society of Environmental Toxicology and Chemistry, Europe, focuses on environmental impacts of ocean acidification. And here's a graph that shows the frequency of conferences and events in detail. As we can see, the trend shows an increase in the number of conferences over the years, particularly highlight that there's a growth from just one conference in 2008 to multiple events in 2022. According to the above slides, it shows that there is a rising frequency of international conferences along with a growing number of scientists and policymakers being invited to participate in these events. This reflects an increased global severity and public awareness on ocean acidification, emphasizing the urgent need to tackle this problem.
Next part is statistics and trend. As the previous introduction said that ocean acidity is due to the level of carbon dioxide, and now the ocean acidity level rapidly increases due to the increases of atmospheric CO2 level caused by the human activity. And according to data from Station Aloha in North Pacific, the global annual mean atmospheric CO2 concentration exceeded 417 ppm in 2022, which is more than 40% of the industrial levels, which refer to global atmospheric conditions, particularly concerning greenhouse gases concentrations and global temperatures that existed before the widespread impacts of industrialization. And the increases of atmospheric CO2 leads to a rapid decrease of seawater pH level. And for the next page, there's a graph you can see it's a continuous dropping level, which is global annual mean surface seawater pH level. It decreases from 8.11 to below 8.05 in 2021, and the ocean acidity had decreased 15% since 1985 and increases 49% since pre-industrial levels. And for impacts of ocean acidification, it affects all ocean basins and coastal areas globally, threatening a marine ecosystem, food security, and economic ramifications. Coral reefs, shellfish, and plankton are sensitive to changes in pH levels, which affecting their growth and survival. And the decline of marine species can negatively impact industries like fisheries and tourism. And for the marine ecosystem, ocean acidification may cause ecosystem disruption. The marine life is facing a twofold challenge, which is decreased carbonate availability and increased acidity, which will harm life forms that rely on carbonate base like shells, corals, and skeletons, and which harm the organisms which are sensitive to acidity and harm the higher up the food chain feeders that feed those sensitive organisms. And then from the next study, which is Del Monaco study, there's some impacts of ocean acidification. And the first one is that coral issue was discovered. Under exposure to different levels of CO2, there was a significant impact on coral tissue loss. In the experiment, most corals exhibited over 50% tissue damage within 15 days and under medium or high CO2 levels, with a daily tissue loss ranging from 4 to 9%. And the contact intensified coral tissues loss across all CO2 conditions, with a higher rate of tissue loss or even death observed under elevated CO2 concentrations, and it will affect the marine life which relying on corals such as fishes and organisms living and hiding in the corals, and cause a negative impacts in food chain. And the ocean acidification also causes significant negative impacts on survival, classification, growth, development, and abundance when all texts are combined, and generally the response most affected by acidification are survival and classification, which are reduced by 27%, and while growth and development are reduced by 11 to 19%. For conditions that roughly represent year 2100 scenarios, there's a 15% reduction in abundance on average, and in these studies, all marine taxa discovered significant negative impacts, not just shells and corals, and the negative impacts causes huge damage on food chain and ecosystem. Thank you.
Acidification is a global issue is because socio-economic impacts. Community that relies on marine resources for their food security, cultural traditions, and means of subsistence are more vulnerable to the problems caused by depleting fish populations and socio-economic impacts in three ways. First, jobs and opportunity like employment. The 1 billion US shellfish industry is vulnerable to ocean acidifications according to a comprehensive national studies published in 2015. It identified several key areas, including the Pacific Northwest, Long Island Sound, Narragansett Bay, Chesapeake Bay, and Gulf of Mexico, and the coastal regions of Maine and Massachusetts. Furthermore, Alaska's fishes which produce over 100,000 employments and account for almost 60% of the country's commercial fish catch, are in jeopardy. Second, global economic value of coral reefs. In this chart, we can see that the economic values of reefs in tourism, coastal protections, fishery, and biodiversity have exceeds over 30 billions. Coral structure in Caribbean and cold water reefs off the shores of Scotland and Norway are being jeopardized by ocean acidifications, with surviving coral communities in Great Barrier Reefs have dropped by 50% over the past 30 years. Fish habitat and the reef ecosystem general resilience are at risk due to this phenomenon. Moreover, indigenous fisheries in Patagonia's waters might be threatened in a similar way. Significant change can be seen in the Antarctic because of the cold, corrosive seas that can absorb large amounts of CO2. Thus, it causes sheltered organisms to dissolve and affect fish, birds, and marine animal food resources. Third, the socio-economic cost of ocean acidifications. Evaluated level of CO2 in seawater, hidden corals in their abilities to form new skeletons, while numerous clarifying planktons face challenges in their developments. In this chart, we can see that mollusks, including oyster and scallops, encounter difficulties in constructing and sustaining their shell, and geophonine mollusks exhibit slower growth rates, increased abnormality, and diminished survival rate. Increasing acidities in ocean waters and reduced carbonate levels could pose significant risks to countless species, the economic system they inhabit, and the human population's reliance on them. Coral reefs, for example, contributing to tourism revenue, seals coastline from erosions, and offer habitats for fish that serves as a primary protein source for local communities, reach the potential global first sales value of ocean fisheries exceeding 91 billions.
To finalize our presentation, it is not hard to see that the ocean acidification is a global environmental problem that all countries around the world need to solve it together. And every people count as a manpower to overcome this issue, as this problem threatens the marine life like coral reefs and shellfish, and ultimately it will affect the entire marine food chain and comes up the aftermath that people have to face the insufficient food resources that come from the ocean.